So this video is to go along with a Word document, a report, and this bit here is just to talk through the code and show the program working. The project is implementing a set of traffic lights, a traffic light controller using a finite state machine on the DE0 board. The traffic lights are at a junction between a major road and a minor road, and we use a timer to create a delay between each stage, and whenever the minor road is at green we have a longer 10-second delay. All the other delays are 1 second. Additionally, instead of using 2 timers, I've cut it down to 1 timer, and we're just looking at different bits on the timer for the desired time delay. We also have added in the functionality for pedestrian crossing as well. That has a 5-second delay, but we'll get to that when we're talking through the code here. So this isn't Quartus here, but if we just jump in here to Programmer's Notepad, we can see things a bit better. So there's technically 20 states, but there's 10 real states and 10 intermediate states that only last for 1 clock cycle, and they basically just reset the timer before moving into the next state. So yeah, there's a 1 second delay on states B, C, D, F, G, H, and then there's a 10-second delay on E and I, and then a 5-second delay on this CRS state, which is the crossing. Also, we have state A. It isn't dependent on any timers, it's only dependent on a push button which simulates a car arriving at the minor road. So if we get into the code then, we'll have our library declarations. We've also declared the LPM library. This gives us use of the LPM functions. So our entity, the traffic lights, we've set this up. This is basically our box, and we have our ins and outs from it. So our inputs, 2 sets of inputs, are the key, which is a standard logic vector 2 down to 0, because there's 3 keys. Where the minor road car present is key 1, the reset key is 0, and key 2 is a pedestrian present at the crossing. And then we have our 50 MHz clock, and then our outputs are 10 LEDs and 4 7-segment displays, which will display a message to the pedestrian crossing. The LEDs will output the state vector and the 6 lights for the traffic light. So in our architecture here, we've defined state type here. There's all our states, say, through all the intermediate states, and our CRS and CRS1 intermediate state. Below that, then we've sort of created a VHDL type there, state type, to represent our 2 states for present state and next state. And then we've also created a signal here called PED, which will go high if there's a pedestrian at the crossing, otherwise it'll be a 0, and we'll test that later on to see if there's a pedestrian there or not. Then we have timer reset, timer Q, which are wires going to and from the time delay, which is an LPM counter. So we see here the LPM counter component, which has its clear clock input and the output Q, which is a 30-bit bus, if you like, state vector or logic vector. So we use bits 29 for 10 seconds, 26 for 1 second, and 28 for 5 second. Time delays, again we'll show you where they are tested down below. So for the port map, where we wire up our LPM counter to signals coming to and from the state machine, we've wired the clear up the timer reset signal clock to clock 50 and Q to timer Q. So out of our 2 processes, our first one here is the synchronous process. It detects changes in the clock, the next state, or key 0. So if key 0 is pressed, then we'll return to state A, or else on the next rising edge of the clock we will make present state whatever is in next state. So this these two processes go in a lockstep manner with the two of each other, so they're sort of dependent on each other. So like if there is a change in present state here, this creates this forces the combinational process to be evaluated, and then within it there'll be changes made to next state, which forces an evaluation of the synchronous process again, and so on. So if we go into our combinational process, then this detects a change in present state, or key 1 and key 2. So that's if there's a car present or a pedestrian present. So the first thing we'll do here is test if there's a pedestrian present. If there is, we'll set the PED signal high, and if not, we'll reset it. If basically if the present state is CRS, if there's a pedestrian at the crossing. I can delete this since this isn't needed. Yeah, so getting into our case statement here. For state A, well, firstly we output our state vector here, and then we set our 7-segment displays to display the word stop to the pedestrians at the crossing. Then next we set up our outputs for the traffic lights. So we have these 6 lights here. So state A, major road is green and the minor road's red. So first thing we do in here is reset our timer before going into our if statement, where we will test if key 1 has been pressed, i.e. if there's a car present. If there has been, we will set the timer to start counting up again, and then we will set next state as our intermediate state A1. Otherwise we'll just sit about in A and wait for this timer to elapse. So when we move into A1, we're only here for 1 clock cycle. We set up all our outputs the same as before in state A, otherwise we would have had an inferred latch error, and then we reset the timer and move to state B. So in state B then, again, it's basically just the same as state A, where we output values to all our output signals here. So we've got our state vector, 7-segment display, still reading stop, and then we've changed to major road amber, red at the minor road. We allow our timer to start counting, and then we start testing here if the timer if the time period of 1 second has passed. If it has, we move into state B, or else we just stay in, we move to state B1, if not we stay in B. So intermediate state B is a little different from the others, because in here we test if there's a pedestrian at the crossing. In this if statement here, just after we reset the timer, if there is a pedestrian at the crossing, then we make the next state CRS, where in that state both roads have a red light, and we'll display go for the pedestrian to go across where it's safe. We do it in this state here because in state C both roads are red, showing red lights, so it made sense to slip a crossing state in at that point. So instead of going to C, we will go to CRS, and then it'll just go back to state A again. So state C basically just the same then as state B. With 1 second delay we have all our outputs, and we move into our intermediate state if the time period has elapsed. If not, we stay there. Then state C1 is our intermediate state. It's just the same as A1 or a lot of the other ones apart from B1 and F1. So basically we just set up our outputs again, same as C, reset our timer, move to D. So in D again, same again here, we allow our timer to count, test if the time period has elapsed, move into D1, and so on. So D1's the same, then E as well behaves the same, apart from we now have a 10-second time delay. Sorry, my typing's really bad here on this laptop. Yeah, so after that then, E1, same again, where we have our outputs the same, reset our timer. F, exactly the same. F1, we test for the pedestrian again at the crossing, and move into state G then. State G is the same, we've got a 1 second delay. We'll move into G1, reset our timer, and so on. So all them states are the same then, apart from when we get to state A, state I. State I is the same as state A, where where the major road's green, the minor road's red. This state is basically just there to allow the main road to the traffic on the main road to flow freely without interruption for 10 seconds before returning to state A, where it's then susceptible to a car arriving at the minor road, where the sequence will begin again. So this has a 10-second delay, as I said, then it moves into I, which then directs it back to state A. So here's our CRS state here, where this will occur in place of the other states where both roads are showing a red light. So instead of the the 7 segments displaying stop, they now display go, and we just blanked out these two here because if we hadn't have, they would have continued to read ST. So then from this point on, it's just the same as any other state. We reset our timer, test if the time period has elapsed. This one has a 5-second time delay. If it has elapsed, we move into our next intermediate state. If it hasn't elapsed, we stay where we are. Here's our intermediate state for CRS. Set the outputs up as normal, reset the timer, and then move to state A again. Here then at the bottom we have a when others, and it's basically just an arbitrary catch-all condition which should never be reached. Basically it's just saying if we ever get to there, make present state A. And that's it for the code. After this I'll just fire in a quick video of the board running the program. We'll go through the sequence of lights uninterrupted, and then we'll go through them again and press the pedestrian crossing button and watch what happens with that then. And as promised, here's a demonstration of the board. So currently we're in state A here, which is shown as a 1 in our 4-bit binary number state factor output here. We're also seeing stop here, the pedestrian crossing message output, and then here we can see that the major road is green, the minor road is at red. So if I press key 1 here to simulate a car arriving at the minor road, we'll see that we jump into state B for 1 second, C, D, E, where we stay for 10 seconds, and once the 10-second delay is up, then we will move into state F, G, H, I, which is the same as A, only we have a 10-second delay. And then we'll move back to A in a second. There we go, state A, and that's us back to the start. I'll also just demonstrate the reset button here. So there it is, flicking through states. We hit reset, we'll come back to state A, and then I'll just demonstrate the pedestrian crossing button here. So if we hit the button for the car arriving at the minor road, we can hit pedestrian crossing in B. It's picked up in state B1, and then we go into this here 5-second delay here where we're safe to cross the road, and then we'll come back to state A, and then I'll just hit it for the next bit again. I'll wait till we get to state P, press the pedestrian crossing button. After here it'll be tested for in intermediate state F1, where it'll then jump into state CRS here. We're told it's safe to go, have 5 seconds to get across, and then back to state A again. So that's basically it.